This is a calorimetry problem. We're putting a piece of hot metal into water, and in this case we're going to determine the heat capacity of the metal from the delta T. Alright, and here's the overall schematics. We have our hot piece of metal put into a cold water bath. They both finish at the same final temperature. So what we want to do is have an expression for delta T of the water bath and delta T of the hot metal. We have expressions for delta T of both entities. So we want to apply the first law. The first law tells us that the heat gained plus the heat lost has to sum to 0. We remind ourselves that it's the water bath that's gaining heat and the metal that's losing heat. And we remember that heat is going to equal mass times a specific heat capacity times delta T. So we apply the equation to the water bath and to the metal. Alright, here's our equation. We have one equation with one unknown. The only unknown here is TF. So we're going to multiply this out, noting that we have to use the distributive property, 47.5 times 4.184 times TF minus 47.5 times 4.184 times minus 20.9. And we do a similar thing on the other side. Here we've multiplied these out. The next step in solving for TF is to collect like terms. So we're going to add 198.7 times TF to 2.93 times TF, and we're going to add the two negative values here together as well. Alright, and this is what we have after we collect our like terms. Again, we're solving for the unknown TF. So the next step is to add 4446.3 to each side of the equation. We have 201.63 multiplied by TF is going to be equal to a positive 4446.3. And we solve TF by division. Okay, our answer can be rounded off to the tens place. The first number to be dropped is 5 or greater, so we're going to round up, and we get our final answer. TF is 22.1 degrees C.